In this video, we're going to talk about the logarithm power rule. So pretty much, we're going to say that we start out with something like log base b of x. Now, what we can do with this log base b of x is we're first going to say, well, let's say we have some number out in front multiplying by the log base b of x. Now, it turns out that if you have something like this, then you can say that this is equal to log base b of x to the power of a. So it turns out that this is true. And so pretty much what you can see is this a could just go inside the logarithm and be the power of whatever's inside there. That's pretty much what that means. So this a becomes there. Or whatever power you have inside the logarithm of that entire thing inside it can be moved out to the front. But why is this true? In this video, we're going to figure out why is this true? How can we verify that this is true? Now, the way that we can do that is we can say we have something like this. We're going to say we let some number n equal the left side of the equation. So let n equal log base b, or let n equal a times log base b of x. So what we have to do is rewrite this thing as the right side of the equation. And so how do we do that? Well, the first thing that we can do is we can first start out by raising b to the power of both sides of the equation. So both sides of the equation right here are now exponents in this case. So when you do that, we of course have b to the power of n is equal to, and so notice what we have here. We have exponents being multiplied together. Now this is really similar to the idea of something like this. 2 to the power of 3 times 5. So in this case, the exponents are being multiplied together. Now there's a rule that we have for when we multiply exponents. And that is, if we say 2 to the power of 3 and take whatever that is and raise that to the power of 5. And so this right here is the rule that we use for whenever we're multiplying exponents. We know about this, and we can apply this thing, we can apply the same idea to what's going on over here, because we're multiplying exponents. But before we do that, let's flip these exponents around, right? Flip the a and the log base b of x around. In other words, so we get b to the power of log base b of x times a. So now what we do is we're going to apply that rule for multiplying exponents. So this is it, right? We're multiplying exponents, and then we just apply that rule, right? Take whatever that is and raise it to that other power. And the reason why we flip those around, right? Multiplication is commutative. The reason why we did that is because we can actually evaluate b to the power of log base b of x. We know that's just going to be x. So this is x to the power of a equals b to the power of n. So this is what we have now. So now what we can do is we're going to just solve for n again. Because, well, we have n in the beginning. We're just going to solve for n. I'm going to go over here and do it. So solving for n, I'm just going to rewrite that. So we're going to solve for n. And to solve for n, we're solving for an exponent. That means we're going to say that n is a logarithm. So n is the logarithm. The base of n is b, so log base b of, and b to the power of n equals x to the power of a. So we get x to the power of a. So this is what n is equal to. And remember, originally, we said n is equal to this. And so notice what we have found. We have found that n is equal to this, and n is equal to that. So that means these things are equal to each other. And so this verifies the power rule for logarithms.